right, everyone, thank you for your patience. The finale of Polkadot Decoded 2022 is about to take place. The man we've all been waiting to hear from has arrived safely from Buenos Aires. Hola, Buenos Aires. We're streaming live across the globe right now. He made it. There was some difficulty in the travels. I will skip over recounting, but he's here. Everyone, Dr. Gavin Wood. And we have a small surprise. We've had our video team editing furiously over the past couple hours, and we've actually put together a surprise video to wrap things up. So we'll play that to go start.
Thanks. Cheers. Yes, greetings from Buenos Aires. I have the honor of being one of the very few people that have enjoyed Polkadot Decoded this year in both summer and winter. So I'd like to give a shout out to Jimmy and his team for getting this together. They did an amazing job in the last few weeks. I want to give a shout out to the Moonbeam guys, to Kathy and Jimena for putting this together. It's a great venue that they got. The sound system is pretty awesome. Definitely would like to enjoy a party here at some point. Good. That aside, and thanks for turning up as well, you guys. This is it's really nice to sort of make a trip over from south of the border and see a few people when I arrive. I want to talk a little bit about, there's a few different things. Oh dear. There's a few different things that have sort of come up on my mind that I would like to sort of go through towards the end of this sort of two-day event. Basically they're going to come down to talking about some high-level commentary of what I see of the world that we operate in, let's say. I want to talk a little bit about how I see ecosystem roles, and I want to talk a little bit about I guess one of the things that a lot of the teams have in common, XCM, and in particular how we're managing XCM and cross-chain trust relationships. So first off, I'm going to be pretty philosophical for this first point. I'm being philosophical because, firstly, there's less chance of being wrong when you're philosophical. And secondly, I think for there are certain things that you can and can't say, especially when you're in a relatively influential position. So you'll have to excuse the abstractness of what I'm talking about, but I hope the messages can be sort of read, I don't know, not between the lines, but I hope people can put things together. So anyway, thoughts on value knowledge, thoughts of knowing things about how, like, what is valuable, how to ascribe value in this world, given that we have incomplete knowledge, right? I think there are two elements that are important about doing this. One of them is like short term, like the term on which we consider the world, which we consider our knowledge, and on which we consider what we want to know. So there is kind of the short term, which considers very much the now, and there is a long term, which kind of tries to extrapolate our knowledge into the future, extrapolate what we want to know as well into the future. And then secondly, there's like the source of information. Typically, there's two basic sources of information. If you're familiar with some of my talks on Web3, you know, I kind of break this down to truth and trust. Another way of putting it is kind of like hope and evidence. Well, another way of kind of putting very similar kind of things is facts versus people. Looking at the facts, working from first principles, versus, hey, looking at seeing what other people are doing. You can form these two kind of axes into a matrix, so you can combine each one. You can look at like value knowledge based upon facts, and the facts are centered around past and present. Like we look at the facts of the past and present, and we care only about understanding the present. You can also say, actually, let's increase our time, the time by which we're sort of evaluating things, still looking at facts. You can start saying, right, well, this is what I know for the past and present, but I will try to extrapolate that knowledge by creating models, by trying to maybe have processes whereby, you know, I try and falsify those models until we get to someday in the future. And broadly speaking, this is I'll explain what I mean by each of these four things, the names, in a second. The other thing that we can do is we can look at people, and we can try and derive knowledge from the actions and behavior of other people. And we can look at what people have done for the past and the present, and we can also look at what we believe people may do into the future. I don't think most of these four ways of determining, like trying to decide what is valuable in this world, I think three of these four things are not so good. I think the thing that is good is when we try to work based on facts, on first principles, and we try to extrapolate that which we know today into the future. And I think, you know, if we're kind of being quite poetic here, I think that's sort of what we mean when we say that's one of the elements of sort of science. All right. Now, what does this mean? I'm going to kind of suggest what this sort of means in more concrete terms. I think people have different comfort and effort levels for how much they sort of care about looking into the facts, working from first principles, versus just kind of seeing what everyone else is doing and trying to understand the world based on other people's or what other people are telling them and their direct behavior, what they can directly see. I think also people don't always necessarily think in the same time period as each other, and furthermore, not even in the same time period as themselves at different points. The other thing to note is that over time, what was supposed to be the future eventually becomes the present, right? Time moves forward, which means if the people who were using the someday column, if they were kind of right, because, you know, the facts, that they were working from legitimate facts using legitimate models, then the likelihood is that they will eventually become of the same opinion in terms of knowledge and value as the people that I've named the 1500. I named the 1500. Does anyone know about this like open letter that was sent a few days ago by like 1500 technologists and engineers? No? No one? Okay, so basically 1,500, you know, supposedly, I don't know, technologists, you know, who's a technologist? I don't know. But they wrote their names down and they said, we think that all of this like Web3 blockchain cryptocurrency stuff is nonsense. And we are scientists or we are engineers and we should know. They wrote this letter I guess they wanted politicians to like take notice of it or something, and they were kind of trying to, in some sense, speak as a broad voice of the engineering industry. They didn't speak for me. I think most of their arguments were nonsense. I think many of their arguments were based upon like what this technology was 8 years ago, and a lot has changed in that time. But nonetheless, and this is kind of what I mean. Like facts can go out of date. Sometimes we understand things better. As innovators and technologists, this is sort of our job. We want to understand the world better, and we want to create new facts, facts that people were maybe only suppositions, propositions, suggestions before. We want to actually prove things about the world beyond some degree of doubt, at least. So my belief, if it's not already obvious, is that the technology that we're working on is actually is going to be instrumental in creating a better world. And in fact, if we continue going down the path of like basically just trusting opaque central organizations with limited, if any, degree of accountability, then we risk descending into dystopia or worse. And overall, my time perspective is pretty long-term, I would say. Okay, good. I know that was pretty abstract. Sorry if it was not obvious what I was trying to get across, but maybe ruminate on it for a bit. Second part of the talk, thoughts on the ecosystem. So this has come up in the past in roundabout ways, and I would like to just spend a little bit of time getting across what I kind of expect and what I want to sign up for as like a member of the ecosystem, and also as like a leader of one of the companies in the ecosystem, founder of the foundation, one of the foundations, I guess, in the ecosystem. How I see the ecosystem sort of working. What I want to get across, I think, most importantly, is that as the CEO of Parity, I'm not looking to like, I don't know, build another Microsoft or something where we have this like ultra integrated, super comprehensive vertical product stack. Yeah, that's not what I'm trying to do here. And I think I want to make it like 100% clear, right? There are certain things that I think I'm me and my team and Parity. Broadly speaking, the Web3 Foundation, I think there are certain things that we are good at, that we want to do, that we want to build, that we want to see, and it's not everything, right? And so this has some like pretty important ramifications for the ecosystem. So like, let's go over what I think the various sort of bits that I'm involved with should be doing: Parity engineering, building core technology, building substrate frame. Polkadot core protocol, tools, some features that we believe are very core to the utility or the value proposition, or that we need to build in order to reduce the risk of particular design opinions that we've made. For example, can smart contracts work on a design like Polkadot? Well, we have to kind of prototype it. That's the easiest way of like guaranteeing that yes, they can definitely work if we can prototype it and demonstrate that they work. Parity Labs is a relatively new setup in Parity, but this is basically tasked with the more cutting edge R&D, like looking into mass scalability, like super scale solutions, looking into potentially using exotic hardware and a few other bits and bobs. Parity ecosystem and Marcoms, some of the other functions of the Parity company, supporting, teaching, incubating, all of this facilitation. The Web3 Foundation, a higher level role, stewardship, evangelism, speaking with a voice that certain elements, certain parts of society sort of find difficult to hear from technologists or from startups. And also doing some of the deep research, looking into like mathematical models, proofs, making sure that what we're building is actually built on legitimate foundations, theoretical foundations. Okay, so but what does it mean then? Why is what's good about it? What's good about like focusing on these specific things and not trying to build, not trying to go like the Microsoft way where we're building this huge vertically integrated product stack? Well, firstly, opportunity. It's opportunity for the ecosystem because we're not trying to like do everyone's job for them, right? We look to the ecosystem to build so much of what people when they come to think of Polkadot, or when they will come to think of Polkadot, as Polkadot unfolds, it's the opportunity of being a part of that, of building a part of this extensive ecosystem. Flexibility on the part of the users, because now the users have many different options, many different teams serving, competing to build the very best products. Innovation. Like, if it's one company building everything, it's very difficult to go down many different avenues all at the same time. Like, you can, of course, have your innovation departments, but by and large, you're already cutting off, you're already at potential avenues, you're already making opinions. It's much, ecosystems can be much more innovative. There are many teams all doing their own thing. Decentralization and all of the things that come with decentralization, reliability, resilience, robustness, long-term success, right? So what are the kind of tenets for this? Well, firstly, and one of the most important things is that we fix opinion only when it's absolutely necessary, yeah? As soon as you have an opinion, as soon as you fix an opinion into a technology, you're basically putting the sell-by date on that technology, right? So we fix opinion only when it's necessary. All opinions ultimately are going to be design errors. So we do it when it's necessary, when there's a singular thing. The Polkadot protocol is a singular thing. We keep it minimal, but if we need to fix opinion, we accept it and we do it. When we don't need to fix opinion, we build stacks to avoid it, right? So basically, we build API levels so that the API may be fixed, but we can have many different things, many different alternatives utilizing and resting on that API. We build reference implementations, but we stay away from official implementations, yeah? Also crucial, as soon as you label something official, you're basically putting a limitation on where your ecosystem can go. We standardize where we need to, and we iterate on those standards with processes in place. XCM is a living standard. There's a document that describes it. There is a GitHub issue tracker where people can put forward suggestions for additional XCM instructions or changes to the format. And most of all, it's an open ecosystem. It must be open because we're not going to spoon feed anyone. We're not going to give everyone a manual in the ecosystem. This is how you do X. This is how you do Y. This is what happens if you need to do Z. No, that's not how it works. Therefore, we have to have a much more open approach. We must each be both investigators, teachers, educators. We must describe things, not proscribe things. And anyone who tells you differently is probably giving you a flawed design, a flawed opinion, yeah? If you're presented with an easy answer, oh, this is how it needs to be, this is the only design, then the likelihood is that they've thought about it a little bit, maybe, they've set it in stone, and now that's it. That's the manual that you're fed. That's not how innovation works. Pluralism, experimentation, and diversity is crucial. We want there to be lots of wallets. We want there to be lots of NFT platforms. We want there to be lots of contract platforms, contract languages, chain explorers, indexes, and all of the other great things that people are building. We don't want to see just one of them, because as soon as there's just one official thing, you're now tying your ecosystem down and you're limiting the potential innovation. Never be afraid to build. You don't need to ask us to build something. You don't need to ask us if you think there's a feature missing. You don't need to wait for us to deliver a particular palette or a particular API. Suggest it. Work with us. But don't wait for us, right? We are not the authority here. That's the whole point of it being a decentralized ecosystem. In our part, we will do our best to teach, to have open development practices, to have an open discussion, and to support teams where we can. So we have a number of programs for trying to make sure that education makes it out into the ecosystem. We have open development. I mean, we've always developed on, using like GitHub, for example, but we have aspirations to make our development practices more open going into the future. Similarly with discussion, we will have aspirations to open up the Parity forums and make it be much more of a community forum framework. We want to make Polkadot standards processes something that is much more inclusive, that people use in order to try and push the Polkadot protocol, but in particular, the standards that rest on the Polkadot protocol forward. And I don't know if you saw my governance talk yesterday, but like the grants program for the foundation has been running for a while, but we really want to push the governance element of the Polkadot network further, faster. We want to make it really be this sort of shining beacon of decentralized decision making. Good. That's the first part. Now the second part is going to be a little more technical. I don't want to get too deep into the weeds here because I'm aware this is more like this isn't the Web3 Summit. This isn't Sub-Zero. So I will do my best not to get too deep into the coding. I want to talk a little bit about XCM. XCM, if you're not familiar with it, it is a language. It's a language that allows consensus systems to make themselves understood between each other. Consensus systems, not just necessarily chains. Chains are the obvious first consensus system, but it works with other consensus systems as well. Basically, any data structure that is held in consensus. So it can work, for example, with smart contracts. What's XCM? How does it relate to XCMP? Sean went over this yesterday. I really want to hammer it down. XCMP is a bit like the phone system, right? It's a means of getting a message from one point to another. In fact, in XCMP's case, it's a means of getting a message between sibling parachains that happen to exist under the same relay chain. XCM is a message form. It's like a language. So like English. English is spoken on the phone system. The phone system is still like the phone system. You can speak English whether you're on a phone system, whether you're face-to-face, whether you're on a video call. It doesn't really matter. It's still English. We're talking about the XCM, the language. Now, there are many kinds of telephone, just to put it out there, in this little analogy. We've got XCMP for sibling parachains. VMP allows parachains to connect to their relay chain and talk to their relay chain using XCM. We have something that I've just today called GPMP, or Grandpa Protocol Message Passing, which basically allows substrate chains to talk to relay chains across a bridge. We also have another form of the same protocol, which allows a substrate chain to talk to not just the relay chain, but a parachain of a relay chain. We also have smart contract message passing, allowing a substrate chain to talk to one of its smart contracts. So there's all these different conduits of passing XCM, right? They're all valid ways of getting a message between consensus systems. So a brief history of XCM started back in late 2020. It's had a couple incremental upgrades, and we are now on to XCM version 3. What are the main changes? Well, there's some changes that make it a more programmable language. There's some changes that make it easy to split up applications across different shards, different parachains. And there's also changes that make it easy, or make it even possible, for it to be used over bridges between different consensus systems. Programmability features, as I said, I'm not going to get too deep into this. Some of the things you can do now, you can have expectations and branching, so you can actually have little programs that can do one thing under one circumstance and another thing under another circumstance when they get onto their destination chain or whatever. We have safe dispatches, which basically means that you can, when you want to transact on a remote chain, when you want to do some particular operation, you can make sure that the chain is still running at the same version that you thought it was when you constructed it in the first place. This can make sure it doesn't do something accidentally that you don't expect. I'll talk a little bit about multi-chain decomposition features. There's a few things here, but one of the most important is remote locking. What this allows to do is to have one chain request that another chain locks some asset, keeps it locked until that chain says, yes, you can unlock it now. This is crucial if you want to have one chain use an asset that exists on another chain, right? I'll give you an example of where this will be used in Polkadot in a second. The bridging features are among a little bit more interesting from my point of view. They're more extensive. And essentially, they allow for the possibility of building very sophisticated multi-hop systems where you can connect bridges and you can have parachains talk across to another parachain that itself is a bridging parachain that goes off to another ecosystem that can then forward a message on into maybe another parachain in that ecosystem, and then eventually maybe make its way down into a smart contract chain. There's a few different features here, and it gets pretty technical, sorry. If you watched, the one thing I'll mention is if you watch Sean's talk, he mentioned that XCM has this abstraction called a multi-location. Multi-location is basically a location held in consensus. It might be, a multi-location example might be maybe the Polkadot relay chain, right? It could be a specific smart contract that exists on Moonbeam. It may be a user account that exists on Statement. These are all locations held in consensus. Now, one of the important points that we're trying to get across before XCM version 3 was that all of these locations, when you referred to a location, it was relative. So you always had to sort of assume that you were already at the sort of the location, and then how do I describe the location I want to reference from the point of view of me? And this becomes very difficult if the location is on a whole different consensus system. Like, it's easier, we can imagine like, oh, well, if I'm a parachain, then my parent location is the relay chain, and then if I want to sort of go to another parachain, then there's like a child location that is that parachain. We can start thinking of it in terms of like directory hierarchies. It becomes quite easy. But it's difficult if we have to jump over into a whole other ecosystem. There isn't really a way that we can have that be relative. And it turns out that one of the conceptual additions that we have now is the universal location. The universal location is a consensus location that is defined as being the parent of all locations that are themselves providing global consensus. Right? So the Polkadot network provides a global consensus. It doesn't rely on any other network to come into consensus, right? It has these validators. They kind of vote on the next block. Yeah, it gets finalized. Easy. That's the Polkadot network. That's what it provides in some sense. It's a global consensus system. Kusama network is similar. It's a global consensus system, right? The parachains are not. The parachains rely on the consensus of their relay chain, yeah? So now what we're doing is we're introducing this conceptual location that exists even at a level higher than the relay chains, or indeed than the Ethereum network, or the Bitcoin network, or any other network that provides consensus. And it allows us, therefore, to have this very useful point that we can reason about when we talk about where bridges go to and from. All right. That's enough of the technical stuff. I want to talk a little bit about like a little bit of sort of vision, what XCM v3 enables. I'm going to skip over this a little bit. I don't want to take too much of your time up. The first and one of the most important things is the functional decomposition of the relay chain. I said I'd mention this, so I'll come back to it earlier. What we want to do is make the relay chain something that actually does what it's named after, that it really just does manage these parachains and act as like a central point for making sure messages that go between them and securing the parachains. This means it really shouldn't be doing stuff like managing governance. It shouldn't be managing validator-nominator relationships. It shouldn't be managing, moving tokens between accounts. This is all not to do with the primary thing of securing parachains, and making sure that they can pass messages between each other safely, right? So what do? Well, we take the obvious approach and we say, let's make a parachain. Let's make a parachain for each of these different functions that we don't want sitting on the relay chain. That's the beauty of Polkadot, that we can do this. But there are some, because at the moment these different functions can assume that they're all on the same blockchain, it means that they can sort of use the different features. For example, staking can use the locking feature offered to it by the balances element of the sort of token accounting elements of the relay chain. So if someone wants to stake their tokens, it can basically say, hey, lock these tokens so that the user can't move them until they've stopped staking. All right. Well, you can't do that if statement is the thing that holds the DOT tokens, and there's a whole other parachain that does the staking stuff, unless you have XCM abstractions to be able to say, hey, lock these tokens and don't unlock them until I let you know it's OK. And this is precisely the sorts of functionality that we're introducing with XCM version 3. There's a few other bits here. I don't want to get too close, because I think Sean already sort of mentioned some of these use cases. There is one other use case I want to talk about that XCM v3 enables. I touched on it in my talk yesterday in Buenos Aires. The Polkadot Fellowship exists as a sort of membership, on-chain membership organization that helps oracleize the information regarding the safety and time criticality of on-chain upgrades. Essentially, it's like it's an expert oracle. Now, there's no real reason to have an expert oracle that is expert in the Polkadot protocol and have two different ones, one for Polkadot and one for Kusama, given that they both utilize the Polkadot protocol. It's like the expert set is going to be basically the same. So it would be cool if we could bridge this. Well, I mean, we want to bridge Polkadot and Kusama. This is already sort of an ongoing effort, soon to be deployed. But wouldn't it be cool if we could use XCM to ensure that this oracle functionality that exists on, well, wherever it exists, whether it's Polkadot or Kusama, can be oracleized onto the other network, so we don't need to duplicate efforts. And indeed, this is one of the things that XCM v3 is intended to solve. Another interesting one would be like maybe a Kusama parachain that holds DOT on statement, able to actually make votes in a Polkadot referendum. This is the sort of interesting cross-ecosystem functionality that bridged XCM can facilitate. This isn't just about like having some tokens be able to be passed. This is about building rich applications that exist across parachains, across shards, and potentially even, in part, where security allows, across ecosystems. Good. There's a bunch of stuff that I could go into with what we want to achieve with XCM version 4. It's mostly quite technical. Don't really think it's going to be that useful to go into now. I would rather spend the time that I have left talking a little bit about some of the things that XCM cannot solve. And I want to make it clear that like there are XCM and XCMP and this technology that we're building can solve a lot of things. But there are some things that need to be solved in different ways. And no effort of adding new instructions or altering how certain elements work is going to change this. Let's take an example. This is an example. This is a real example. This is something that is like, I mean, this specific, the names are not real, but the underlying problem is real. There's already a GitHub issue open with quite a big, long sort of conversation in it. Suppose there's a user on a parachain. Let's, for argument's sake, say that's a user on Fala, And they want to send some tokens that are not native to Fala. So let's suppose, again, for argument's sake, they want to send some AUSD. So it's native to Akala. And they want to send it to some other third place, some other parachain. Let's say it's Moonbeam. Now, not only do they want to do that, but they want to do something on Moonbeam where they, where they're doing it under the authority of this user, of this Fala user. So maybe they want to execute some sort of smart contract call, and they want to make sure that these tokens, this AUSD, is in their account. Who knows what it is? Maybe it's, I don't know, some sort of liquidity mining or DEX, or it doesn't really matter. But they want to do something on Moonbeam, in a contract in Moonbeam, with this AUSD, okay? AUSD is held as a reserve asset on Akala, right? And Fala, Akala, and Moonbeam, they don't have any special trust relationships here. They all just, like, they do their thing. They treat each other as independent networks. So at the moment, this must be done in 2 steps. The first step is that we do a reserve asset transfer. So basically, Fala instructs Akala to move some of the users, some of the Fala AUSD from the Fala account to the Moonbeam account. And then as part of this, it also sends an onward message. This is to say, Akala sends an onward message to Moonbeam, letting it know, hey, you've got a credit, and this is what you should do with it. Credit it into this user's account, this Fala user's account. Okay, that's the first step. This basically moves the AUSD into the account on Moonbeam. The second step is then for Fala, on behalf of its user, to tell Moonbeam, hey, execute this smart contract action, whatever it is. Do something with this AUSD and this smart contract. Now, a question arises. Well, why don't we just do it in one step? Why doesn't Fala, on behalf of its user, just basically tell Akala, transfer the AUSD, send it on to let Moonbeam know, and then have Moonbeam execute this smart contract action directly, right? This is the question that is being posed to, to us, the XCM guys. Is there not something we are being asked that we can add to the XCM language, or some extrinsic that we can add to a runtime, some special transaction or something that can do this in one step? And the answer is no. XCM cannot solve this. The reason XCM cannot solve this is it's not a language issue. The issue isn't with the language. The issue is with the trust relationship, right? There is a messaging, the first message, because we're doing a reserve asset transfer, because Akala is where the AUSD sits. Fala must ask Akala to transfer it over to Moonbeam. That's the first message. Fala asks Akala to do something, sends a message there. Now, Akala is the only one that Moonbeam can trust to tell it that it's received the AUSD. So the second message must be from Akala to Moonbeam. That's fine, that's how it works. But then we want to make the Fala user, or we want to do some contract execution on Moonbeam on behalf of the Fala user. Who's going to tell Moonbeam to do this? Moonbeam doesn't trust Akala to tell it what it should be doing on behalf of Fala, right? Why would it? It's like, it's Fala's user. Why would Moonbeam trust Akala to tell it to do something on behalf of Fala's user? No, doesn't make any sense. So there must be a third channel here. There must be a third message that is directly from Fala to Moonbeam. And this is why it has to be in 2 steps. And it's nothing that we can add to XCM to prevent this. But it's not a great solution. There's a race condition for a start, right? You're sending 2 messages out. You're sending one from Fala to Akala to get this AUSD transferred across. Then you're sending a second one from Fala to Moonbeam to tell it to do something in the smart contract with, we assume, this AUSD. Well, what happens if the second one arrives before the first one? It breaks. It doesn't work. Something goes wrong. The smart contract doesn't have the AUSD in it at the time. Whatever. I don't know. But like, it doesn't work. It's not a great UX either. And the performance isn't so good, because in theory, you've got like 3 different things happening. despite there only being 3 different endpoints, right? In theory, if this was sort of perfect, if they all trusted each other, let's say, then there would only need to be 2 messages because, you know, there's just an initiator and sort of 2 destinations. So how do we fix it? We can't fix it by adding to XCM, and we can't fix it by changing XCMP, or at least not without major architectural alterations to create like multi-party channels and how do we fix it? Well, the answer is Spree. So I've talked about Spree in the past in a fairly circumspect fashion. I want to just reference it here today now to point out that there are real ecosystem use cases that people would like, you know, that teams are finding they want to be solved pretty soon, that can be solved. And they can only be solved in this way. What Spree does is it allows trust-free remote logic execution. Basically what it means is, in Polkadot, we can make sure that each of these parachains adheres 100% according to the logic that it sets for itself. We can make sure that no transactor can cheat the chain that it's being transacted on. We can make sure that even the chain itself cannot cheat its own governance or its own rules for upgrading. But what we can't do is make one chain be able to trust that another chain won't upgrade itself and somehow stop working in the same way, right? This is just fundamentally, chains are sovereign entities. If they want to upgrade and, I don't know, eat everyone's money that happens to be sitting on the chain, they can. Like, it wouldn't be a great look for the chain, but they are sovereign entities. There is nothing that Polkadot can do. I mean, in part, it's an unsolvable solution in general, because how could anyone other than like the chain's logic itself know how best to describe the expectations that people have en masse about the chain? In some sense, code is actually law. But what Spree can do is it can set some boundaries to this. And it can say, OK, you're free to do what you want within your own runtime, your own logic, your own business logic that you control, that you can upgrade at will. But we can add little bits of business logic that you are not free to change. We can add a bit of business logic, for example, that guarantees that if a message is received from a certain endpoint that is not destined for you, but in fact is destined for somebody else, we can guarantee that that can be forwarded such that the final destination can trust that it was not tampered with along the way, that it won't be duplicated, and that it won't be dropped. This is what we would call a Spree XCM enclave. Spree enclaves are these little bits of logic that guarantee certain things. And this, if we want to like look back to our problem example, it would work a little bit differently. Fala, rather than sending directly to Akala, would actually send to this special, protected little bit of logic that sits next to Akala, but that Akala can't touch, and that guarantees certain expectations regarding what will happen with ongoing routing, making sure that, for example, if a part of this message was destined for Moonbeam with the authorization of the Fala user, it will be, without any kind of tampering or changing, be forwarded onto Moonbeam, and Moonbeam will be told that it does indeed come from Fala. And because it's the Moonbeam special module that is interpreting it, it knows that the Akala special module could not have tampered with it, because it knows that Akala has no control over the logic of this module. How does it work? Well, I'm sorry for the technical stuff, but basically it's an entirely separate runtime. It's an entirely separate business, like chain business logic. It just happens to sit right next door. So it's whenever Akala is sort of processing a block, this thing is also available processing a block. And the two can talk to each other, right? They can talk directly, relatively quickly between each other. Synchronous, So it can ask something, and then it can get a reply basically immediately back. But crucially, these little bits of logic are not set by the parachain itself. They're set by the relay chain. So it's almost like the relay chain can give these special, non-negotiable bits of functionality out to each of the parachains. And these non-negotiable bits of functionality can kind of talk in between themselves and do things that that parachains cannot trust, in all honesty, trust each other to always do for fear of, if not malicious behavior, potential bugs. That's Spree. It's working through the research and design phase. Hopefully, we will begin doing some prototyping during this year. And with that, it's the end of my little talk here. I hope I didn't bore you too much with the technical stuff. Thank you.
Good job. Thank you very much, everyone, for coming to Polkadot Decoded 2022. It's been a great couple days. The graphic on the screen was actually wrong. We were closer to 100,000 viewers across online in the four locations. So thank you all for coming, and I hope to see you next year. But if you're not going to be around, I'll see you later for a couple drinks. Peace.